Okay, so then we're going to do a little multiplication of polynomials and monomials, and I want to remind you of a couple things. So I'm just going to remind you of one thing from exponents. We're going to do more on exponents later, but I'm going to remind you. So the way exponent multiplication works is, let's say I have x cubed times, we're doing multiplication, x cubed times x squared, right? And usually this is just written without that dot. It's just usually written like that. It means multiplication. Now, there is this rule that some of you may remember, that x to the a times x to the b is x to the a plus b. That I add these exponents. And that's absolutely true. The result I'll get here is x to the fifth. The reason that works, and I just want you to understand this, like you can think through this, x cubed, exponents are like multiplying the same thing over again. So x cubed is x times x times x, and x squared is x times x, 2 copies. So, and then really this rule comes from counting. It's like I have 5 copies of x and I just write that down, right? This rule is not like, it's not a super complicated rule, and sometimes people don't know where it comes from. It's like, how many copies of x do you have, and just write that down. So you just add them. Okay, so when I make this a little bit more complicated, so let's say I have these two binomials, like negative 9x cubed times negative 2x to the fifth, I'm going to put pieces that look alike together and multiply those pieces that I can. So I use the commutative property. Do y'all remember this commutative property of multiplication that lets me move things around? So I'm going to move this 2 up next to the 9, and I'm going to move this x cubed up to the next to the x to the fifth. So I'm going to do negative 9 times negative 2 times x cubed times x to the fifth. And I'm going to think about these two problems, like this problem and then this problem, because those are the pieces I'm kind of grouping again, the stuff that I can do, right? So I get 18 here. Negative 9 times negative 2 is a positive 18. Negative times negative is positive. Negative plus negative is still negative, so be careful there. X cubed times x to the fifth is x to the eighth. So the total answer is 18x to the eighth. The multiplication in here doesn't go away. It doesn't magically turn into addition, but it's just 18x to the eighth. Okay? Okay. So now if you do this now I just want to extend this. Is what I want to do. And so now we need to be able to multiply two polynomials together. And you probably remember, so example, multiply x plus 5 times x plus 7, right? Okay, and some of you may remember there are a couple different ways to do this. One is to think about this as distributing, and another is FOIL. There's the third, box method, so I might do those. So the real thing is I have to multiply this x times both of these pieces, and I have to multiply this 5 times both of these pieces. So this is what we think of kind of as distributing if you're seeing this. So, and sometimes people will just write those problems out. So they'll be like, it's x times x plus x times 7 plus 5 times x plus 5 times 7. And then they'll simplify. X times x is x squared. 7 times x, we usually write the 7 first, and that's just 7x, 5x, and 35. And then you add like terms. That's these two middle terms. X squared plus 12x plus 35. Okay, now this is really similar for these are called binomials, where they just have two terms. So I'll remind you of FOIL. We'll do this. Let me do another problem. FOIL, first, outer, inner, last, which will really do the same thing as distribution here. So the first are multiplying the two first terms together. Outer are these two outer terms. Inner is right here. And last are the two last terms. So you just do all those combinations and add them together. And I'm going to keep this, I'm going to be careful right here. Do you see this red negative? You cannot lose this sign right there. It's attached to the 3. So I'm going to treat this like a negative 3. Okay, so my first terms are x times x again. Outer is x times 4, and I'm going to add that together. Inner is negative 3 times x. And the last is negative 3 times 4. Don't lose that negative. X times x is x squared. 4x minus 3x, or you can write a plus negative 3x, but I usually write a minus 3x because it's simpler. And I'm lazy. And a plus, and that's a negative 12, plus negative 12 is the same thing as minus 12. And then again, I'm going to add like terms together. 4x minus 3x, or a positive 4x minus 3x should be 1x. X squared plus 1x minus 12, which normally people will write just as x squared plus x minus 12. Okay. There's one more method you might have seen where you make a box and you just put these pieces and then you calculate the insides of the box. So let's say this example is, I'm just going to do this like 9x minus 3 times x minus 8. So then you just put these like like there's 9x, you put a negative 3, and here's x, and you put a minus 8. And then you just multiply. Like this box is 9x times x. This box is negative 3 times x. This box is 9x times negative 8. And this box is negative 3 times negative 8. And usually people won't write what I have just written. So what you'll usually see is just the result. So I'm going to show you I kind of am showing you more work than people usually show here, just so that you understand. So this is 9x times x. I'm just, in my head, I'm like putting those together and I'm just multiplying. I know that's 9x squared. Over here in my head, I'm doing these, right? I'm going to erase these. So second step is right here. Boop, negative 3x. Then I like kind of move back, and then my next step is 9x, and I come down and pick up, and I'm thinking about those two, and that's negative 72x. And then the last step, I take negative 3 and I multiply by negative 8, and that's 24. Okay? Then I add these up, and in this, if you have kind of a normal binomial, you'll find like terms here, and people will sometimes add those in one step. So 9x squared, negative 72 and negative 3 is negative 75x, and then plus 24. Okay. Then this box method works. The reason people like the box method, well, maybe before I do another one, I'm going to remind you of something. So the thing you'll forget is problems like this, x plus 6 squared, you have to use FOIL or use the box method. This is x plus 6 times x plus 6. This is not, I just want to say this out loud, x plus 6 squared is absolutely not x squared plus 6 squared. That's not how squaring this thing works, because you're going to get like this thing and this thing, but you're going to miss this middle term, right? So you can either use FOIL or the box method. x6, I get x squared, 6x, here's a 6x, here's a 36. Then I get x squared. The two 6x's are 12x plus 36. And this is called a perfect square trinomial. So when we go to factoring, you'll remember. Trinomial. this thing is like 6 times 6, and this thing is 2 times 6. So you get these 6's that show up in this kind of unique way. Other special multiplications that you might remember and that kind of lead to factoring are things like this, a difference of squares. So if I have x minus 4 times x plus 4, if you're doing FOIL, that's fine. I'm going to keep doing this box. I kind of really like the box. You kind of lessen the number of mistakes that you're making. FOIL, you're doing a lot of stuff in your head. In the box, you kind of like just write it out. So this is x squared. These like terms, this inner and outer term, negative 4x plus 4x just becomes 0. Those are opposites, so I'll get x squared minus 16 as the result here when I multiply it out. And for factoring, that's called the difference of squares when I go back the reverse way, right? So when factoring, I'll go, like right now I'm multiplying. Factoring is like a reverse of multiplication, so I'll go back this other way. Okay. Let me do one more example. That's it. I'm going to do this box method for a more complex example. 9x plus 8 times 2x squared plus 4x minus 8. And so the box you can use with however many terms. That's another reason people like it. So I'll do 3 terms on top and 2 terms along the side. So this is 9x and this is 8. This is 2x squared, 4x, and minus 8. And now I'll just fill in all these boxes. So this box comes from the 2x squared and the 9x. So 2 times 9 is 18. And x squared times x is x cubed. Then I'll go over here. 9 and 4 are 36 x squared. Negative 8 times 9 is negative 72, and then I have an x. Then I go down to the second row, and I'll get 16x squared. 4 times 8 is 32x, and negative 8 times 8 is negative 64. And then again, you'll see kind of the reason people like this box method is there are my like terms there, and there are my like terms there. They're kind of real close. So I'll get 18x cubed. 36 plus 16 should be 52x squared. Check that for me. Negative 72 plus 32 should be 40x minus 64. And then that is written in standard form because I'm decreasing. This is degree 3, 2, 1, 0. And it's simplified. I don't have any more like terms to put together. Okay. So I will say this is a very quick review of polynomials, and I wanted to also mention, and I'm going to post this, if you need more help, there is, I'm going to post this link to this Khan Academy, it's like a module, and it will go into more depth on each of these. So like, if you need more help or more examples, let's say just an introduction to polynomials, there's that. There's some more examples. If you need, we'll do average rate of change later, but if you need more help on adding and subtracting polynomials, there are more explanations and examples there. And then if you need more help on multiplying, there are more examples on multiplication there and down here, right? So the multiplication especially, we spend a lot of time on when people first start to do this, because it leads later to factoring, because factoring will undo the multiplication. And so if you can do some work now, understanding. But I'll put this link there in case you need extra help or extra places to look. Then here's this will be a resource for you to look at, and so that you can get some extra help. Some of you will be fine. Some of you really need to do this. So I would say if any of this feels super unfamiliar, you should come over and do this Khan Academy stuff. Um, like just to help make sure that you're set for the class. So I know that this will be optional, but this work will pay off because the course will feel less like magic and more like you understand what's actually going on. So it will be easier to understand later on.